Hello everyone, welcome back to ANR Academy. Today we are going to discuss how to find number of symmetric relations from given set capital A to itself. Before going to discuss total number of symmetric relations, let us see what is symmetric relation. See the definition. If A comma B order pair belongs to a relation, then if B comma A also belongs to the same relation, then we can say that R is symmetric, which is true for all order pairs which are belongs to that relation. Suppose there is a relation R. Relation nothing but that is subset of cross product of two sets. The entries are clearly order pairs. Suppose if you have an order pair A comma B belongs to that relation, reverse of this B comma A, if it is also belongs to that same relation R, then only the relation is called symmetric, and which is true for all order pairs which are belongs to that relation. For example, if I select capital A is a set with entries 1 comma 2, cross product of these two sets contain order pairs 1 comma 1, 1 comma 2, 2 comma 1, 2 comma 2, and we know that every subset of A cross A is a relation. I am going to write subset 1, subset 2, subset 3, subset 4. Suppose first subset that contain entries 1 comma 1, 2 comma 2. Next subset having entries 1 comma 1, 1 comma 2 and 2 comma 2. Next, suppose that just 1 comma 2, 2 comma 1, and fourth one I am going to choose 2 comma 2, 2 comma 1. These subsets are relations. We know the definition of relation: every subset of A cross A or A cross B. You may select same set or different sets cross product. Yes, let us cross check whether these four symmetric or not. To check symmetric relation, you have to select for all order pairs, you have to cross check this condition. If a pair belongs to that relation, then reverse of the pair also lies on the same relation. Yes, I am going to cross check 1 comma 1. Reverse of 1 comma 1 again 1 comma 1, that is clearly in that relation itself. Next 2 comma 2, reverse of 2 comma 2 also again in the same relation, so that it is symmetric relation. That's why here I am writing it is symmetric. Next S2 1 comma 1, 2 comma 2, they reverse again 1 comma 1, 2 comma 2. But for 1 comma 2 there is no 2 comma 1. Reversing the entries, you will get another pair. That pair also must lies on that relation. But here there is no such pair in the reverse order, so it is not symmetric. Next 1 comma 2, 2 comma 1. Yes, for 1 comma 2 reverse 2 comma 1, and for 2 comma 1 here you have 1 comma 2. So it is having symmetric pairs, so that the relation is called symmetric relation. Reverse of 2 comma 2 itself, but there is no reverse for 2 comma 1. There is no pair in the reverse order. There is no 1 comma 2. So that it is not symmetric. So that pairs are non-symmetric inside. So it is non-symmetric relation. Yes. Definition is very clear. For all order pairs belongs to that relation, their reverse order also must lies on the same relation. Let us discuss now how to find number of symmetric relations from A to A itself. Suppose A having n entries totally, then cross product of A itself that gives all order pairs, and the order pairs in matrix notation here there is n cross n matrix with entries 1 comma 1, 1 comma 2, 1 comma 3 and so on, 2 comma 1, 2 comma 2, 2 comma 3 and so on. In the same way n comma 1, n comma 2, n comma 3 and so on, n comma n. Here the entries I am going to divide diagonal wise and non-diagonal wise. Total there are n square elements, in which diagonal entries are clearly n. Non-diagonal elements, from entire n square elements, if you remove diagonal n diagonals, then n diagonal elements, you will get n square minus n is number of non-diagonal entries. And non-diagonals are divided into two portions, upper half portion, lower half portion. Upper half portion consists n square minus n by 2 elements, lower half consists n square minus n divided by 2 entries. Now let us cross check number of symmetric relations from A to A. The total number of symmetric relations from A to A, I am going to write like this. Number of ways of selecting pairs from diagonal elements and number of ways of selecting pairs from non-diagonal elements. Yes. Why? Because you must select order pairs and they must be symmetric. Then only entire set capital R is called symmetric relation. So symmetric relation is depending upon symmetric pairs. Yes. And the pairs maybe you can select from diagonals or non-diagonals. There are two chances. So that I am writing diagonal entries multiplied by non-diagonal entries. Here I am going to write the total number of ways of selecting pairs from diagonal elements. Suppose that if you select only one pair from diagonal entries, it is symmetric. How many such possibilities are there? Total there are n entries, 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4 and so on. So selection of only one pair, the possibilities here NC1. Suppose you need to select two pairs, 1 comma 1, 3 comma 3, or you may select 2 comma 2, 5 comma 5. How many such ways are there? There are total NC2 chances. From out of any n diagonal entries, you can select 2. 1 comma 1, 3 comma 3 or 2 comma 2, 5 comma 5. In that way, there exist NC2 entries are possible. Or you may select one of the relation without diagonal elements also. How many such chances are there? NC0. So here without choosing diagonal, you can frame a symmetric relation. One chance. Next, you may select only one pair from n diagonal entries. Another chance. Next, selection of only two pairs from diagonals. In that way, I can write up to NCN. So this is about selection of pairs from diagonal elements. Next, go for non-diagonal entries. How many non-diagonal entries are here? Non-diagonal elements are total n square minus n. Suppose that there is a relation that is having 1, 2 is an entry from non-diagonal. So, automatically if it is symmetric, 2, 1 also present on the same relation. What I am observing here, just if you select only one non-diagonal entry, then automatically its reverse 2, 1 also must present on that relation. Yes. Here non-diagonals are divided into two portions, upper half and lower half. Suppose it is the entry from upper half, then here you have to select an entry from lower half. Let us cross check the number of ways of selecting one pair from upper half and entry from lower half. Yes, from upper half total there are n square minus n by 2 entries. From upper half there are n square minus n entries, from which selection of one pair, the possibilities I can write n square minus n c1. Any one of all these you can select. You may select 1, 2 or 1, 3 or 3, n, whatever it is. So how many such chances are there? Selecting only one pair from upper half, that is n square minus n whole divided by 2 c1. Upper half n square minus n by 2. From that you can choose only one. Yes. If you select one of the entry from upper half, then what are the possibilities to select from lower half? Only one entry. If you select 1, 2, then 2, 1 only one chance. But selecting one pair from upper half has many chances. You may select this one, this one, this one. So total how many chances are there? N square minus n divided by 2 chances are there. That can be written as n square minus n by 2 c1. Only one element selection from upper half. After selecting that, from lower half, only fixed element you have to select. That is only one way. There is no other way to choose different kinds of elements from lower half. Yes. Suppose that if you select two entries from upper half, the chances n square minus n divided by 2 c2. You may select the combination 1, 2, 1, 3. What I am saying, suppose there are two pairs if you selected from upper half. For example, if you select 1, 2, 1, 3 from upper half, automatically from lower half you have to select 2, 1 and 3, 1. This is fixed. No other chance here. It is depending upon this one. It is fixed depending upon this, and selection of two pairs from upper half, total number of chances n square minus n by 2 c2. And it is fixed only one chance. No other combination possible to select two pairs from lower half, remember. So here I can write, and there is one more chance. There is a chance to create a symmetric relation without choosing any entry from upper half also. So without using non-diagonals also, you can create a symmetric relation. So n square minus n by 2 c0 also possible. So here I am going to start by writing n square minus n divided by 2 c0. No non-diagonal selected. Without using non-diagonal also, you can create a symmetric relation. Here in this example, it is very clear. 1, 2, 2, 1, it is symmetric. There is no principal diagonal 1, 1, 2, 2. So without Yes, it is without diagonal elements. And here another example. If I write 1 comma 1 2 comma 2, it is symmetric with only diagonals. Non-diagonals are not selected. So there is a chance to get symmetric relation with the help of symmetric, with the help of diagonals, or with the help of non-diagonal entries also. So here, without using non-diagonals, no non-diagonal element is selected. That is one chance. Next, plus. You may select only one non-diagonal entry. Only one non-diagonal entry. From upper half, if you select one, and then from lower half, there is a fixed chance, only one. So in this way, you have to continue up to n square minus n divided by 2, c n square minus n divided by 2, entire values, all of them selected. And here there is only one chance to select from lower half. Yes. NC0, NC1, NC2 and so on NCN, that is equal to 2 to the power of n. This is from the concept of sum of binomial coefficients. And here it can be written as 2 to the power of n square minus n divided by 2. See, for example, if you have 1 plus x whole power n, using binomial theorem, it can be written as nc0 plus nc1x plus nc2x square and so on ncn x power n. Substituting the value of x equal to 1, what happens, observe, it is 2 to the power of n, and in the right part you get nc0, nc1, nc2 and so on ncn. So sum of binomial coefficient is clearly 2 to the power of n. So 2 power n here, 2 power n square minus n by 2 here. And in the next step on simplification, it become 2 to the power of n plus n square minus n divided by 2. That is 2 to the power of n square plus n whole divided by 2. So this is the result to find number of symmetric relations from A to A. I hope you have understood everything. The students, those who are watching my videos, please subscribe the channel and don't forget to like, share and comment. Thank you so much.